Question 7. 2 dice are thrown. Copy and complete the two-way table to show all the outcomes. So the first die, the possible outcomes are 1, 2, 3, 4, 5 and 6. The second die, the possible outcomes are also 1, 2, 3, 4, 5 and 6. So you need to copy this out and fill in the blanks. So some of them are already done. So 6, 1 means we landed on 6 on the first die and 1 on the second die. 1, 2 means we landed on 1 on the first die and 2 on the second die. 2, 3 means we landed on 2 on the first die and 3 on the second die. And 6, 6 means we landed on 6 on the first die and 6 on the second die. So you need to fill in the other blanks. Once you've done that, you can answer question 2, 3 and 4. So first of all, filling in the two-way table. We have 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1 in the first column. Then 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2 in the second column. Then 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 3 in the third column. In the fourth column we have 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 4. In the fifth column 1, 5, 2, 5, 3, 5, 4, 5, 5, 5 and 6, 5. And in the last column, the sixth column, we have 1, 6, 2, 6, 3, 6, 4, 6, 5, 6 and 6, 6. Now that we have this filled in, we can answer question 2, 3 and 4. So question 1, how many outcomes are there? So we can see there are 6, 6, 6, 6, 6 and 6. So 6 times 6 gives us 36 possible outcomes. The fact that we were asked how many, when we're asked how many, that means multiply. So we could have just said, well, there was 6 options for the first throw and 6 options or outcomes for the second throw, and 6 times 6 gives us 36. Question 2. What other method could you use to count the number of outcomes? Well, we've already answered that. We could have said 6 times 6 gives us 36. Question 3. How many outcomes have the same digits? For example, 2, 2. You can see I've highlighted in blue all the outcomes that have the same digit. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So we end up with 6 outcomes. If we had been asked what's the probability that when 2 dice are thrown, you end up with the same digit, the answer would be 6 over a total of 36. So there are 6 possible outcomes where the digit is the same, so 6 is our numerator, and we always divide by the total number of outcomes, which is 36. So the probability that we get the same digit if we were to throw 2 die is 6 over 36, which simplifies to 1 over 6. Part 4. Is the outcome 1, 3 the same as your outcome for 3, 1? Explain your answer. So there's 1, 3 and there's 3, 1, and they look the same, they look quite similar. But actually, no. 1, 3 means we get 1 on the first die, then 3 on the second die. And 3, 1 means we get 3 on the first die and 1 on the second die. So they are actually different. It's the order that's important. Question 8. A spinner lettered A, B, C and D is spun. Another spinner numbered 1 to 5 is spun. Copy the two-way table to list all the outcomes. So you need to draw this into your copy and fill in the blanks, and when you have, then you can answer the next few questions. So let's have a look at this a bit closer. So the first spinner, the possible outcomes are A, B, C and D. So you can land on A, B, C or D with the first spinner. With the second spinner, you can land on 1, 2, 3, 4 or 5. So this one is already done for us, so C3. So this means we landed on C for the first spinner and we landed on 3 for the second spinner. So you need to fill in the other blanks. So here is my two-way table filled in. So let's have a look at this a bit closer. So A1 means we landed on A for the first spinner and 1 for the second spinner. A2 means we landed on A for the first spinner and 2 for the second spinner. A3 means we landed on A for the first spinner and 3 for the second spinner, and so on. B1 means we landed on B for the first spinner and 1 for the second spinner. B2 means we landed on B for the first spinner and 2 for the second spinner, and so on. So in our first column we have A1, B1, C1, D1. In the second column we have A2, B2, C2, D2. Then A3, B3, C3, D3. Then A4, B4, C4, D4. And then A5, B5, C5 and D5. So now that we've filled in our two-way table, we can answer the rest of the questions. So question 2, how many different outcomes are there? So if we count them up, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 different outcomes. A much quicker way to do this would have been to say, well, there was 4 possible outcomes for the first spinner and 5 for the second, and 4 times 5 gives us 20. Question 3. How many outcomes have an odd number? So 1, 3 and 5 are all the odd numbers. So we've got A1, B1, C1 and D1. So there's 4 odd numbers there. Then for the 3s we have another 4. And for the 5s we have another 4. So 4, 8, 12 outcomes are odd. Question 4. How many outcomes have an even number? So 2 and 4 are even. So we've got 4 outcomes that contain a 2, 4 outcomes that contain a 4. So 4 plus 4 makes 8. Alternatively, we could have said, well, there's 20 in total. Take away the 12 that are odd, leaves us with the 8 that are even. Question 5. How many outcomes have a vowel and an even number? So you can see here I've highlighted in blue, there's only 2 outcomes that have a vowel and an even number. So A2, A is a vowel and 2 is even. And A4, A is a vowel and 4 is even. There are other even numbers in our two-way table, but there's no other vowels because B, C and D are consonants. So there's only 2 outcomes that have a vowel and an even number, and they are A2 and A4. Question 6. How many outcomes have a vowel or an even number? So they can have a vowel and an odd number, or they can have a consonant and an even number, or they can have a vowel and an even number. And in probability, or means add. So we just add up anything that contains a vowel and anything that contains an even number. So you can see I've circled in green anything that has a vowel or an even number. So A1 has a vowel, A2 is a vowel, A3 is a vowel, A4 is a vowel, and A5 is a vowel. So they all have vowels in them because A is a vowel. Now we know that B, C and D are consonants, so none of the rest of our outcomes have vowels in them, but B2, C2 and D2 all contain an even number, 2 is an even number, and B4, C4 and D4 again all contain an even number. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there was 5 outcomes that had a vowel in them. So A1, A2, A3, A4, A5. And then we had 6 outcomes that had an even number that is not already contained in this first set. So B2, C2, D2, B4, C4, D4. So the ones that I had circled up here in green pen. So in total there's 11 of them. So if the question had said, what is the probability, let's say, that the outcome is a vowel and an even number? Well, remember there was 2 outcomes that were a vowel and an even number. So the probability that if you spin the 2 spinners, that you would end up landing on a vowel and an even number, the probability of that is 2 over 20, because there are 2 outcomes that contain a vowel and an even number. And we divide by the total, which is 20. There are 20 possible outcomes altogether. If a question said, what's the probability that when you spin the spinners, you land on a vowel or an even number? Well, we would have 11 over 20 because there are 11 outcomes that contain a vowel or an even number. They're circled in green. And again, we divide by the total, which is 20. There are 20 possible outcomes altogether. So when we move on to questions containing probability, at the moment we're just looking at questions where we're listing outcomes, but ultimately this is what we're aiming for. We're aiming for changing our outcomes or using our outcomes from our two-way table and producing probabilities. But remember, probability must always be between 0 and 1. It can never be less than 0 and never be greater than 1.